The world has right now close to 1 billion cars, and we might double the number of cars on the planet by 2050. So that's going to have a big, big footprint in terms of our demand for resources to move all those vehicles around.
We're pulling up carbon that's been stored underground and burning it in our automobiles and putting all that carbon dioxide into the atmosphere. If we don't reduce that, we could have changes in the climate that we could never recover from.
This has kicked off people looking at a whole range of other alternatives to petroleum in your tank.
When we started the ethanol program in Brazil in 1975, nobody talked about reducing emissions. This was not an issue at that time. First, and most important, we didn't have money to buy oil anymore after the first oil shock. We were importers of oil. And today, more than 50% of all cars use ethanol instead of gasoline.
Sugarcane to ethanol is an incredibly efficient process. They extract the sugar from the cane. The sugar goes into these large fermentation tanks with yeast that naturally produces ethanol. They use the rest of the plant to generate heat to distill the ethanol and turn it into fuel, not putting excess carbon dioxide in the atmosphere. And you get out about 7 times the energy you put into growing the sugarcane. In the US, when we produce ethanol from corn, for every unit of input of energy, we get about the same amount of energy out. So we're really not gaining anything. We need a better process. So the crops that we're looking at are crops like switchgrass. This is a native grass that grows without a lot of water and on marginal lands that we could turn into energy farms, but that's a really complicated process. We extract the glucose from the plant, and then we feed that glucose to a yeast that we've engineered to produce hydrocarbons. And that yeast takes in the sugar and gives us this high-energy molecule.
The role of biofuels is quite tricky. And this really boils down to the fact that there's only so much arable land, and growing fuel for our gas tanks is yet another demand on that landscape. But there are a variety of crops that do not compete directly with food, and finding ways to utilize those types of crops first, that's very attractive. And this equation is really wide open right now.
Imagine that you could have one process that could take in sunlight and carbon dioxide and turn it into fuel. And imagine if that didn't involve growing anything at all.
Materials chemists like myself want to do artificial photosynthesis to improve on the process that nature does in real photosynthesis. All we really need is a light absorber that absorbs sunlight. We also need a catalyst like iron or nickel. Ultimately, our pieces are going to be contained in something that is easy to roll out, where in would come sunlight and water. You would vent the oxygen to the air, but the bottom would wick out your liquid or gaseous fuel that then you could use for our cars and planes and storage.
If you think about how long it's taken for us to build up the petroleum industry, we can't hope to reverse that overnight. It's a huge change in our infrastructure, and that means basic research needs to be done now and by as many people as possible. We have a long way to go, but I'm confident that we'll get there.